So yeah, what we'll be doing in this whole post-contest discussion is that we'll be discussing these 4 problems. We'll be going in this order: A, B, C, and D. And you guys are free to unmute anytime and discuss your approaches, the way that you approach this problem. And it might be better than my approach in some cases. It might be worse than my approach in some cases. So yeah, I mean, better approaches are always welcome. The worst one are also welcome, but obviously the final approach that we'll be discussing would be the best one. Right. So let's get started with the first problem. And let me just open all of these here. Cool. So was this problem difficult, by the way? Like, anybody found this problem difficult? This first one? Difficult to understand maybe? Okay, somebody saying I approached C with DP, wasted my complete time on DP approach, did not get time to view D. Okay, I think the C problem is, has like a greedy solution. It does not have a DP solution. So yeah, we'll be discussing that. But anyway, let's discuss the first problem first. So this problem goes like this, that you have a bunch of 3 doors. Okay. You have 3 doors, 1, 2, and 3, all right. And each of these doors has their keys. For this door 1, the key is 1. For door 2, the key is 2. For door 3, the key is 3. So essentially, if you have, let's say, keys 1 and 2, you can open this door and you can also open this door. But you cannot open this door if you don't have key 3. Right. There is another thing that is given to us in this problem, which is that there is a certain key at the back of a certain door. For example, if I tell you at the back of first door, you have key 2. So if I open the first door first, then if I already have key 1 in my hand, and if I open this door, so I will get this key 2 out of it, and I can open this door as well. Now, if behind this door I had this key 3, then I can use this key 3 to open this door. Right. So in this problem, not all 3 doors will have a key behind them. One door out of these 3 will have a key 0, and 0 signifies that there is no key behind it, right? So what you want to do is that initially you have a key present. It might be 1, it might be 2, it might be 3. You need to figure out whether using some combination of opening the doors, you can open all the doors or not. Fine. Is the problem clear? Maybe you can write a +1 or -1 in the chat if it's clear or not. Okay, cool. So what's the approach now? Okay, you have a certain key in your hand. Let's say these are the doors that you have. This door has a key 0 behind it. This door has a key 1 behind it, and this door has a key, let's say, 2 behind it. And if I tell you that you have which key? Let's say you have key 1. Which door can you open at this point? Tell me, which door can you open? You can only open the door 1, right? If you have key 1 with you. But what you realize after opening this door is that you don't have a key behind it. So can you open any other door here? Can you open any other door here? You cannot, right? But the problem is not like this, obviously. It's not like, you don't have a key entirely. For example, if you look at the keys that you have in overall, you have key 1, you have key 1 here, and you have key 2 here. What is given in this problem is that either you have, all the keys, you have 1 key in your hand, right? But the other 2 keys that are there behind the doors, they are not going to be same as your key. Fine. So let's say I give you this as the question now, that you have key 3 with you. Now can you open all the doors? What you do is you go to this door and you open the door 3 and you get key 2 out of it. So now once you have key 2 out of it, can you open this door? Because now you have key 2. And once you open this door, you also get key 1. So now using key 1, you can open this door, right? This one. So this way you can open all the doors. Fine. So how would you approach this problem? What would you do in order to figure out whether you can open all the doors or not? What if you had something like this, that behind this door you have key 1, behind this door you have key 2, and behind this door you have key 0, and initially you have key 3 available with you. Now can you do this? Can you open all the doors if this is the condition given to you? You have key 3 in your hand. You try to open this door, but you don't find any key behind it. So essentially these 2 doors still remain locked, right? So the approach is very simple. It's more like just brute force. All you have to do is this is door 1, this is door 2, this is door 3. What you have to do is, given the key, let's say you have given key, key given to you is key X. All you have to do is go to the door X and pick out the key that is there behind this door. Fine. If you find 0, can you solve this problem? The problem is very simple. You have to just go to this door X and you have to pick out the key that is there behind this door. Fine. And if you can do the same step, how many times? If you can do the same step 2 times, then you're done, right? return a of x is equal to 0 or a of x, a of x is equal to 0. Exactly. What I'm saying is that, you know, you should not encounter 0 in your first two steps. Right? The first door, I'm not able to understand this. The first two doors we are opening. Yeah, exactly. That's the whole approach. First you open this door, you find the key that is there behind it, and then you open the next door after that. If you're able to open two doors, then you're done. That's the whole point. If you're able to open two doors. The first two door basically should not have a 0 key behind them. Fine. So this approach is fine. Like, you know what you do, you have x, so you go to a of x, and you check whether this first door has a key 0 or not. If it has a 0, then your answer is no. Then if it does not have a key 0, then, you know, you go to a of x. And if this is 0, then also the answer is no. But if the value here is non-zero, then the answer is yes. Fine. So is the approach clear to everyone? This is like an order of one solution here. Fine. And I did it in a different way actually. Like, I did not, you know, spend a lot of time thinking about the first, you know, whether we can open the first door or whether we can open the second door or not. What I did was this. This is my approach, although this is a little complicated. I shouldn't have done it like this. But what I did was this. I have, you know, a certain bunch of keys that I have in my hand. These are the keys that I have. Okay. This is the set of keys that I have. And this is the set of keys that I don't have. What I do is, from the set of keys that I have, I go to all the doors that I can open. Fine. I go to all these doors that I can open, and what do I do? Behind these doors, if there is any other key that is present, I bring that key and I put it into my set of keys that I already have. Fine. And at the end, I mean, this is like a simulation. You will only simulate it for 3 steps. And after 3 steps, all you have to check is that your set of keys that you have, they are 3 or not. The number of keys that you have are 3 or not. Fine. So this is another approach.
I think for the duplicate keys, I think when I applied this, there was a situation when I didn't get the second test case right. But when I did it for the duplicate keys also, like while opening the first door, if I'm getting the key from it, I'm making it 0 also. So if I encounter a 0 again on that thing, so I was printing no. Then the solution got accepted there.
Yeah, I think you would get a TLE if you just use, you know, just simulate it without any checks. That's the point. If you simulate it, it can, you know, get the same key again and again, right? You go to the same door, you get the same key. This can go into an infinite loop. But what you have to do is this. If you're simulating something, let's say, you know, this is the set of keys that you have. This is the set of keys that you have. And this is the set of keys that you don't have. After every simulation, should you not add an additional key to this set? That's my point. If after any simulation, I mean any step in the simulation, you're not able to add a key to this step, then that just means that this whole step is going to repeat again and again, and you will never find a new key. Right? So this is what I've done here. Although this is like, you know, a little complicated, and this will work when n is going up till something like, let's say 100. Right? N here was just 3. You had just 3 keys. But this will work when n is going up till something like 100 or even up till 1000. So what I'm doing is, this is the set of keys that I have. Keys.insert x. This was the key that I already got. So I inserted it into the keys that I have. Fine. After that, what do? I go to all the keys that I have and I check that behind these doors, is there any other key that is present? If it is non-zero, I just insert it into my set of keys. And in every simulation, I just check that, okay, what is happening here? Yeah. So after every simulation, I just check that, you know, the size of my keys should increase. It should not remain the same. If it is remaining the same, then that just means that I did not do any, you know, useful work in this step of simulation. So that step is going to repeat again and again. Fine. So do you guys understand how this solution will work for, you know, n going up till something like 100? Or n going up till something like 1000? Like, you know, you just simulate that after every step, you want to get new keys. I just hope this solution is clear, like this one. The first solution is obviously very simple. All you have to do is just check this, you know, a of x, either this is equal to 0 or a of x, either this is equal to 0. If any of these two cases arises, then the answer is no. Otherwise, the answer is yes. Fine. Tell me if there are any doubts in this one, this approach. Cool. So let's close this problem and let's move to problem B. Fine. And this was one
there
problem.
won't be any need there. Excuse me.
Yeah, sure.
There won't be any need for like even 100 also. It will be working for 3 also. Like there are 3 doors, and if we'll be working for them only and making them 0 while we get the key of that, so that will also work.
Oh, no. What I'm saying is that if the number of doors that you have right now, if the number of doors and the number of keys, right, in this problem you have 3 doors and 3 keys, right? I am saying that this solution will work even when the number of doors and the number of keys are 100 or even up till 1000. That's what I'm saying.
Okay, got it. Got it.
That would be like a different problem, obviously. But that's like a simulation. What I'm saying is that after every step of simulation, you should do some productive work. That's my point. If in any step of the simulation you're not doing any productive work, that means you have to end the simulation. Fine. So let's close this
yes,
problem.
got it.
Cool. So this was the second problem. This problem again was very, very simple. Although I did take up a lot of time to understand it. I mean, I'm not sure why did I take up so much time to understand it. What I did was that I could not understand this problem and I went to C directly. And then I came back to B. So maybe I read the problem, wrong, something like that, but it did take up a lot of time for me to understand it. So I'll just quickly explain what the problem says. So you have this, number line, and there are buildings on these number line, right? So there are these buildings, and all you have to do is like, you have to go from a particular building to another. For example, if I tell you that you have to go from this building to this building, then there is some cost that you have to pay from going to here, from here to here. Fine. What is the cost? The cost is that after, every step that you take, if you're taking a down step, what that means is, if you're going down in a step, you have to pay a value. Let's say you're going from building of height X to building of height Y, then you have to pay a cost of X minus Y. So tell me if, I'll be paying a cost at this point or not. Let's say I go from this building to this building. Will I pay a cost or not? To actually go from this building to this building? I will. What about going from this building to this building? Will I pay a cost when I'm going from this building to this one? I will not. So the cost is only being paid when you're going to a building that is, that has a height smaller than your current building. Fine. So let's say the height of this building was something like 9. The height of this building was 6. This was, let's say, 8. This was 7. And this was 10. So how much cost will you have to pay for going from here to here? So first of all, you go from 9 to 6, you pay a cost of 3. From going to 6, when you're going from 6 to 8, you don't pay any cost. When you're going from 8 to 7, you pay a cost of 1. And from when you're going from 7 to 10, you don't pay any cost. So the total cost would be, my solution was showing TLE. Is this for the first problem or is this for the second problem? Second problem. Yeah, I mean, we haven't really discussed the solution yet, right? So let's discuss that at the end, your issue. So can you see that the cost here was something like 4? Cool. So this is something that you have to just check, and it's not like you only go from left to right. You don't have to just go from left to right. You also have to go from right to left sometimes. Prefix sum plus suffix sum, exactly. So this is very simple. If you have, let's say, an array, this array is representing the size of the buildings. So tell me what are the number of steps that I will have to take in order to go from here to here. Let's say I already know the number of steps to come from here to here are X. Okay, and the height of this building is H, let's say HI, and the height of this building is HI plus 1. How many steps will I require, to go from building 1 to building, let's say this one, I plus 1? If I already know that the number of steps I have to take from for going from building 1 to X are, when I'm going from building 1 to I are X. What I'm saying is this, that you're standing at building 1. To go from 1 to I, you have to spend X coins. Now, in order to go from 1 to I plus 1, how many coins will you have to spend? You will just spend, obviously you will spend coins when HI plus 1 is what? When HI plus 1 is less than HI. If it is greater than HI, you won't spend any more coins. But if HI plus 1 is less than HI, then the number of coins that you'll spend are X plus what? HI plus, HI minus HI plus 1. Right, so this is nothing but like a prefix sum. You compute the prefix sum, and whenever, let's say, somebody tells you that you have to go from building A to building B and you're going from left to right, your answer is nothing but prefix sum of B minus prefix sum of A. because what is happening? We are basically going from A to B. So we don't want to include the steps of going from here to here, but we want to include the steps of going from, this point to this point. So that will be included in prefix of B minus prefix of A. And similarly, when you're going from right to left, you can compute a suffix sum for this, and that will be same. So if you're going from A to B here, then the suffix sum would be something like suffix of B minus suffix of A. Right, and let me just show you the solution for this. So prefix is defining, the cost that you'll have to pay when going from building 1 to building I. So prefix of I is nothing but prefix of I minus 1 plus. If, ARR of I minus 1 is greater than ARR of I, then I just, include that value. Otherwise, I don't include anything. Similarly for suffix, you go from right to left. And then at the end, when you have to print an answer for a query, you just check if you're going from left to right. Then you print, this is the case when you're going from left to right. You print the answer of prefix of B minus prefix of A. Otherwise, you print suffix of B minus suffix of A. So any doubts in this one? And what is the time complexity of this? Time and space. Time is order of n. What about space? Space is also order of n, right? Okay, what was the time complexity in the previous solution? Time and space in the previous one. In problem 1. Cool. It was order of 1 in both cases. Space and time both were order of 1. Cool. So any doubts in this problem, or should we move to problem C?
Yes, Priyansh.
Okay, cool. So let's move to problem C. Okay, how many people here were able to do this problem on their own? I mean, obviously the contest has just ended, so you would have only done it on your own unless you're cheating. So how many people were able to do this on their own? I was stuck at B. Why were you stuck at B? Were you not able to understand it, or like you could not come up with a solution? In my case, I spent a lot of time on B because I could not understand the problem. I'm not sure why that happened. Okay. So let's look at problem C and let's see what this is saying. So in problem C, you have a string which is like what? Which is a regular bracket sequence, okay? Fine, you have some opening brackets. You have some opening brackets, you have some closing brackets, something like this. Fine. But in this, substring, in this whole string, what has happened is that you have, removed some characters and you have replaced them with question marks. For example, if I remove this, I will have one opening bracket here and this will become a question mark. Let's say I remove this one as well. This will become a closing bracket here and I have a question mark again. Let's say I remove this one as well. This will become a question mark and I will have another closing bracket. Similarly, let me just remove this one and I'll put a question mark and I'll have another another closing bracket. So in this problem, all you have to do is, once you're done replacing these, brackets with question marks, you have to tell me if there is only a unique way to replace these brackets back into the string to create a regular bracket sequence, or are there more than one ways? Fine. So can you tell me if there would at least exist one way in this problem, if you're doing something like this, that from a regular bracket sequence, you are removing some brackets and replacing them with question marks. So would there always be at least one sequence that will give you a regular bracket sequence? Okay. So tell me, if I tell you that, this is your string, this is the thing, I mean, this could be anything, question mark, something. I mean, I'm not really concerned about what is there in the string. If I tell you that there are 3 opening brackets left and 4, let's say, closing brackets left, don't consider what is there in the string. I don't care about what is there here. Okay, I don't care about this. Sorry, this should be opening and this is 4 closing. Okay, I don't care about what is there in the string. I don't care about where exactly is the question mark. I am asking you to give me one sequence that will always work. One sequence that will always work in any string if I tell you that, these brackets have been actually removed from the regular bracket sequence. Tell me one sequence that will always work. You will not even have to check it if it works or not. Open, close, open, close. No, this will not work. Not open, close, open, close. Let's say I tell you that you have a string as something like this. This is your sequence. Let's say you had a string as something like this. And now you have, let's say, what you have this. Let's say this was your string. Okay, let me draw it properly first. Let's say this was your string, and I told you that you remove this character, you remove this character, you remove this character, and you remove this character. So what will your string look like? Your string will look like something like this, right? Question mark, opening bracket, question mark, what else? Closing bracket and closing bracket, right? What you're saying is something like opening and closing will always work, right? This is what you're saying. You put one closing, you put one opening, you put one closing, you put one opening, you put one closing. This is what you're saying, right? But this will not always work. Sorry. No, I'm not sure what you're saying here. No, the question said there is only one possibility for question mark at 0th index. The problem is not this. The problem is that there is already a valid bracket sequence, okay? There is already a valid bracket sequence. You remove certain brackets from it and you replace it with question marks. My point is which, now you don't know what was the actual bracket sequence, okay? You don't know anything about that. All you know is that there are certain question marks, and if I were to replace these brackets in the exact same order that were there previously in the regular bracket sequence, that will work. That is something that I know from the problem statement. What the problem statement is asking you to do here is check if there can be two sequences in which you put this, opening, closing here such that it works. 0th would be obviously, yeah, I mean that is obviously opening only. That makes sense. That if you have let's say a question mark on the very first index, that will be an opening bracket. That is fine. But we're not concerned about just this thing. I am asking you to tell me if I can replace these. Okay, one sequence could be something like this, right? Let's say I tell you that you have 3 opening and 1 closing. How can you put it in terms of these question mark? A solution that you can do is something like this. This, and this. Give me another solution that I can put here. If I have these question marks, I can do this as well, right? I can do this thing, this, and this. But the point is, the question is asking you, can you have more than one sequence? Here, this is the first sequence, this is the second sequence. The question is asking you, can you have more than one sequence such that overall the sequence, overall this string becomes a regular bracket sequence? That's the question. So my question to you right now is, give me a sequence that will always work. Give me one sequence that will always work irrespective of what the string is. If let's say I have 3 opening and let's say 2 closing, can I say that this will always work? Opening, and closing. It doesn't matter where the question marks are, but this will always work. I put all the openings first and then I put all the closings then. Will this not work? Think about it. Will this always work or will this not work in some cases? Will it not depend upon? No, it will not depend upon the rest of the string. That's what I'm saying. That this sequence will always work. If I tell you that you have A opening brackets and you have B closing brackets, then what I'm saying is that you put opening brackets, A opening brackets in first A question marks, and then you put B closing brackets in the next question marks. Right? Will this work or will this not work? It is already given to you that these brackets have been picked up from a regular bracket sequence. Okay, let's try to prove why this will work and why it will work or why it will not work. Let's try to see. So let's say I give you any sequence, something like this, and let's say I have something like this. Okay, and let's say this becomes a question mark. This becomes a question mark, this becomes a question mark, this becomes a question mark. What do you have now? Now you have 2 opening brackets and you have 2 closing brackets. What I'm saying is that all you have to do is just put these opening brackets first and then these closing brackets. This will always work. Because initially also they were working, right? I am even, simplifying it by putting all the opening brackets first and then the closing brackets. I'm even simplifying it. That's my point. So will this always work? Putting all the opening brackets first and then putting all the closing brackets, irrespective of where the question marks are. This will work, right? Cool. Now the question is very simple, right? The question is asking you, tell me if there exists more than one sequence that works. So what is the first sequence that always works? It is that you put A opening brackets first and then you put B closing brackets next. This always works. Tell me, if I were to just check for one more sequence, what would be that one sequence that I will have to check if it works or not? The problem is very simple. You just have to tell me if there exists more than one sequence. And I've already told you that this sequence always works. So what is that one extra sequence that might work? No, somebody saying open, close, open, close, open, close. No, this might not work in some cases. Can't you do something like this? You put A minus 1 opening brackets, you put one closing bracket, then you put one opening bracket, and then you put B minus 1 closing brackets. Will this not be like the first sequence that you should try?
Hello,
Yeah,
Priyansh.
yeah.
Yeah, so actually, it would be better if you could tell us your thought process behind these constructions, because these greedy questions, like how did you come up with these constructions, and your claim regarding this will always work and open, close, as I mentioned before, it will, I mean, there can be counter examples where it can fail. So I want to know how do you think regarding these lines, yeah.
Okay, what you're saying is
about the constructions, yeah.
What you're saying is open, close, will it work or not, right? This is what you're asking.
No. So you are concretely saying it won't work. I believe you. So you might have found counter examples.
It's not like.
But I'm more interested in.
Here's the thing. When I'm saying it might not work or it will not work, it's not like I have proved it here right now. It's just my intuition at this point. What I'm telling you is, a better solution at this point. This is what I'm saying. If you look at this thing, okay. What you first of all try to understand this thing. How do you say a bracket sequence is regular or not? What is that one condition that you have to check in order to say whether a bracket sequence is valid or not? You tell me this.
Okay, so let's say we have a bracket sequence. Then the necessary and sufficient condition would be the prefix value up till a particular point will always be should always be greater than equal to 0, and at last the prefix value should be 0.
Exactly. That's the whole idea behind it. That's how I came up with the solution. So I'll tell you how did I actually build up from that, right? You're looking for this, right?
Yeah. Okay. I want to know the construction.
Right. So understand it this way. What I'm saying is that how is a sequence valid? A sequence is valid if, let's say, I say that an opening bracket amounts to +1 and a closing bracket amounts to -1. Then a bracket sequence is valid if for the prefix sum. If you consider the prefix sum going from left to right, the prefix sum at any I is greater than equal to 0, and the prefix sum at n, which is the last index, is equal to 0. That's the condition, right, for a regular bracket sequence.
Yeah, these are sufficient and necessary.
Cool. Now the question is very simple. The question is that you pick up some sequence, some brackets, and you replace them with question mark. Okay, you replace them with question mark. This is what you've done, right? Now my point is, you would have picked up some opening brackets here and some closing brackets here. So what is that one thing that you should do to maintain this condition? Should you not put all the openings first and then the closing ones? Right now the sequence that is given to you is already valid, right? You have been given a valid bracket sequence, and uske andar se you have picked up these opening and closing brackets and replaced them with a question mark, right? So if I were to put these opening and closing brackets back into my string, what would be the best string that I would want to consider if this is the condition that I have? I would want to put all the openings first, right? So that the prefix sum, even if it could be negative in some cases, it remains positive when I put all the openings first.
Okay, I got your point.
Right.
So your best case scenario would be putting them
exactly. That was what my point was. If you put all the openings first and then the closing, irrespective of where the question mark is, if the condition is already holding, this prefix of I is already greater than equal to 0 for the initial string, if you replace all the question marks in a way that you put all the openings first and then the closing, then this condition will always hold. That's my point. Right?
Got it.
Cool.
Clear.
So now what I've given you is one solution, right? This solution will always work. You put A opening first and then you put B closing. Now my question is, what is that one extra string that you should try? This is one, right? All you have to say in this problem is whether you can bring up one more sequence or not. You tell me which would be that one more sequence that would, might work, that might work. And if that does not work, then nothing works.
A minus 1 opening brackets, and then B minus 1 closing brackets, then a single opening bracket and closing bracket.
Exactly. ये कर लो ना, this is even better. You put A minus 1 opening brackets and then you put one closing, then one opening, and then you put all the remaining B minus 1 closing. And check if this string also works. If this also works, then your answer is no, because you've constructed at least, 2 cases here. Okay, one more thing. If you have constructed this second case, do you need to construct any more cases, or can you just print no in your answer?
Yeah, print no.
You can just print no, right? So my point is, if you just have to check whether you can bring up 2 sequences or not, you should just check 2 sequences, and you should check the best 2 sequences, right? So if the first case does not work, this A A opening and B closing, if this does not work, will we ever have a second case? Tell me this. If this does not work, this first one also doesn't work, will we ever have a second case? Because that's the best string, right? Now my point is that the second best string would be nothing but A minus 1 opening, 1 closing, then 1 opening, and then B minus 1 closing. So if the second one doesn't work, will there be any other string that can work after the second one? Because that's the second best. First you considered the best string, then you considered the second best. So that's the whole solution. Fine. Now my point is that, do you even need to construct the first one? In the problem, it is already given to you that the sequence given initially is a valid bracket sequence. So do you even need to consider the first one, or can you just consider the second one and be done with it? Should you do both of them, or should you do just one of them? That's my question. The second and the first, or just the second?
One of them. We need to do only one of them.
Not one of them, only
The
this
second
one.
one.
Yeah, only the second one. Yeah, exactly. So that's what I've done in this problem. And now, do you guys understand the logic behind this? I think that was actually a very good question. Whoever asked this, that, how did you come up with the solution? So thanks for asking that, because I might have not, discussed that. Cool. So this is what I'm doing.
Priyansh,
Yes.
how did you come up with the, this will be a greedy solution and not a DP solution?
I mean, you can do a DP solution as well, but I mean, you'll have to think, right, that what will be the state, what will be the transition. I never thought of, I mean, I did think about DP first of all, because these were like, this is like a very standard problem. If you have regular bracket sequences and you have question marks and all of that stuff, it mostly is like a DP problem only. But what I realized was that, you had to consider a lot of cases here. So my point was that, if I just consider 2 cases and just say whether they both are possible or not, then I'm done. Right? So that actually gave me a hint of going into the greedy direction. That I just have to check for two strings and not all of them. If I had to check for all of them, then definitely it was DP only. Will DP work under? It depends on what your state is. I'm not saying that this problem does not have a DP solution. I am not saying this. But you'll have to think of a state and transition. And I mean, it might just get very, very difficult to think about it.
And the second question was, when you were discussing it, you said that first put the open, like all the open brackets, the opening brackets first, and then the closing brackets. So in the question, like when I read the question, I thought that rearranging the brackets, like if on the second position only it is given a closing bracket. So I think can we rearrange that to a further location?
Yeah, that's also one solution. What he's saying is that you have these question marks. This is the first question mark. Let's say this is the second question mark, and you have some more question marks here. What you're saying is that instead of checking for all one more sequence, you just check whether you can replace this, closing with an opening or not, right? From here. This is what you're saying, right?
Yes, I was not sure that we can do this or not. That is why I didn't come with can rearrange it.
Yeah, I mean, there are a lot of other solutions as well. The solution that I discussed was more like, it was very logical and it was less greedy as such, because I gave you a logic behind it, right? How this prefix sum is working. But there could be multiple solutions.
You can arrange it.
Yeah, I mean, there
like
could be
we
multiple
can
solutions.
rearrange them.
One solution could
like
be...
if even the closing bracket is on the second position.
Yeah, go on.
If we are like given a closing bracket on a second position also, you can further move it to the last of the string. Like
Yeah, you can do that. Yes. Okay, I'll give you a better solution, or like a more a solution that you can understand even better. So if let's say you have this sequence, this is the question mark sequence. Okay, the sequence of brackets in the question mark. Let's say I tell you that this is the sequence of question marks. Okay, this is there. Tell me if you can rearrange this to get a bracket sequence valid or not. Okay, I think this will not work. Let's not discuss this. This is not a valid solution. Any other greedy ideas that you have in mind? Somebody saying I actually tried a DP solution and it worked for uh, how many valid strings possible, and yes, that's greater than one. So yes, but okay.
I
I
had
think
a slightly different solution.
yeah, just a minute. Let me just complete this.
Okay.
I think
Sure, sure, sure.
this solution that you are talking about, this DP solution, this would have been something like order of n square. So if that was order of n square, you can obviously compute the number of the number of valid uh, these valid sequences that you can construct using DP, but that would obviously go to order of n square. So that would be something like you are standing at a particular index, let's say I. Your DP would be something like this: DP of I. You're standing at this index, and what is your sum? What is your prefix sum? Right? I think that is something that you would have done. But yes, that would be order of n square. Could you please summarize as my? I think you can watch the recording. This will be posted on YouTube. So let's not like explain this whole thing once again. But yes, somebody was talking about some other solution. You're free to speak now.
Yes. Okay. So what I did was, first we have the string. I traversed this string twice. First once from left to right and then right to left. I want to correct this string once. Okay. So I actually want to remove any obvious question marks. So take a sample so that I can
Okay,
explain.
you want
it.
to remove any obvious question mark. So let's say a question mark
Yeah.
here is a question
So
mark.
whenever the depth in this bracket sequence is 0 and I encounter a question mark, coming from the left to the right, I replace that question mark with an open bracket.
Okay.
So if the sequence is open bracket, question mark, close bracket, close bracket. So if the sequence is question mark, question mark. So the first one, it's obvious that the first question mark has to be an open bracket.
This has to be an open bracket, right?
And then again, traversing from right to left, we encounter a question mark with depth 0. So that has to be a closed bracket.
Right. Yeah.
Yes. First, I do this correction on the string. After this is done, I then count the number of open brackets and the number of closed brackets. Okay. So and then my solution was just a guess. I was not sure, but I don't know. I thought this would work. So what I did then, after this correction, I counted the number of open brackets and the number of closed brackets.
Okay.
Then I said that if any one of this open frequency of open brackets or closed bracket is equal to n by 2, where n is the length of the string, then I say that there is a unique solution possible. Otherwise, there is no unique solution possible.
Sorry. What you're saying is if any of them is greater than 1, right? Greater than 0, or what?
No. So if basically that's, so if any one of, in a regular bracket sequence, both the number of open brackets and the number of closed brackets has to be equal to n by 2.
Right.
So after I do this correction, I count the number of open brackets and the number of closed brackets. If any one of them is equal to n by 2, then the other question marks are already fixed. They have to be of the other kind.
Right. Obviously, yeah.
So this is what I did. If any one of the open brackets or closed bracket is equal to n by 2, then I just print yes. So this is unique. Otherwise, I print no. This was my guess, but it obviously has a hole.
Did it work? Did it work?
Yes, no, it didn't work. I got a wrong answer, but it works on every test case that my friends have given me and I have tried. So I really can't find the hole.
Okay, so what you're saying is that you started correcting the string from left to right?
I also think this approach is a bit up to the question, because when you are saying that you are arranging the first opening brackets there, like all the opening brackets first and then all the closing brackets, you are rearranging the opening and closing brackets. So I think that is not what the question says. We need to find like the brackets which are given, they have to be fixed over there. I don't think we can rearrange them.
Then what's the problem? You tell me.
I think that while arranging like the way they are arranged, we only need to check if we are changing question marks in more than one manner, if they are correct or not. I think that was the question.
How are these two things different? They both are same. What I'm
I'm
telling
really
you
not
is
getting
that,
this latter part, which you are
see,
saying that if we can put all the closing brackets, like all the opening brackets first, and all the closing brackets after that.
see, what you have to do is you have been given a set of question marks. You have to replace these question marks with opening and closing, right? This is the question. You have to replace these question marks with opening or closing brackets, right? What I'm saying is that if you have remaining opening brackets as A and you have remaining closing brackets as B, this will come from these question marks obviously. You replace the first A question marks with an opening bracket and you replace the next B question marks with a closing bracket. This is what I'm saying. I'm not saying that you put all of them together like this and then this. So is this making sense now? I'm not sure like if your question is clarified, if your doubt is clarified, or like you tell me what the problem statement says and I will tell you how what I'm doing is the same. So it's up to you.
So you are just converting the first A brackets, like A question marks, to the opening one, and the latter B part to the closing bracket.
Right.
And then you are checking for the second test case, like for the A minus one opening brackets and then a closing bracket, and then you are checking it the like B minus one again the closing brackets.
Right.
Okay, got it. I thought that you are arranging the like
No.
even the
We're not concerned
brackets.
about. We're not concerned about the brackets that are already there. Okay. We're only concerned about the brackets on the question mark. These are already fixed. This one. These are already fixed. What is not fixed are these question marks. So when I say I am replacing the, I'm putting the first A A opening brackets and then the next B closing brackets. I am talking about replacing the question marks and not the actual. How to find A and B? This is very simple. In a string of, let's say, in a string of size 2n, how many opening will you have and how many closing will you have? You will have n opening and n closing. And now let's say I tell you that in the given string, there are something like n minus 2 opening. Then how many opening do you have left if there are n minus 2 opening? 2, right? And similarly for the closing one. Had a doubt in DP approach. Yeah, you can talk about your DP approach as well. But I'm not sure if there is a sense to discuss an order of n square solution here. But in case you have some doubt, you can obviously, discuss that.
Hello. Hello, Priyansh.
Yes.
It's not completely about the DP approach, but while solving, if we get any case where our valid strings are more than 2, like is there any way to stop the recursion tree there?
I think that's the exact same thing that I thought. Like what I thought was, just construct one string and try to construct one more and don't try to construct any more after that. So that's how I actually got to this greedy solution. But I'm not sure if you can do something like that. Like there is no way to actually, like break out of recursion if you have more than 2 ways. Because how will your recursion work? Like understand it this way, no? If you're at the starting of the string, unless and until you reach the end of the string, you don't know whether your sequence is valid or not. Right? So unless and until you don't reach this point, you have no idea whether it is valid or not. And by the time you reach this point, you would have already constructed 2 to the power n ways. जब तक end तक पहुंचोगे तब तक तो खत्म हो चुका होगा ना. Already 2 to the power n ways you would have considered. Right? So there is no way to actually break in the middle. You can only break at the end, but by the time you reach the end, you would have already constructed all the cases.
It would already been exceeded. Yeah,
exactly. You cannot answer whether you will have more than one way from this point. If you're starting your recursion from here to here, you will never be able to tell whether you can have more than one ways from this point. You will only be able to tell it once you reach the end, because that is the point you will understand whether the whether the sequence that you've constructed is valid or not. Can you think of any DP solution which will not? Okay, so it's not like you can think of a DP solution for any problem. It's not how it works. I am not sure if I can think of a DP solution here. Obviously, an order of n square solution is coming to my mind, but in order of n solution here, no, I don't have any idea for that. Because if you have to construct so many cases, it's already going into order of n square. If you're at a particular index, okay, See how will you like think about DP? If you're at a particular index, what do you have to store? You also have to store how many opening have you used and how many closing have you used, right? In order to just track that, that is like order of n, and this order of n is this index, so it's already order of n square. If you're at any index, to understand how many opening you have used and how many closing you have used, you need to store it somewhere. That's how DP works. So that's already going order of n square. But yes, a homework problem for this would be try to tell me the number of ways that you can replace these question marks to construct valid sequences. The number of actual valid sequences. Okay. So that would be like a homework, and think about order of n square DP there. I think that is something that a lot of people would have done. But anyway, any more doubts in this problem? Problem C. Okay. And is the idea of how I got to the greedy part clear as well? Like how did I actually come up to that thing that construct one case and then construct just one more case? Is that also clear? Okay, cool. So let's end this problem here, and let's move to problem D. Now there was somebody who was asking in the chat if problem D was easier than problem C. In terms of idea, I think yes. If you know some data structures, I think you can even do this problem without some data structures. But if you have some idea of sparse table, range queries, all of that stuff, this is very, very easy, this problem. So if you look at my submission times, this hardly took around, how much? I think 20 minutes to solve this problem. Yeah, this took only around 14 minutes for me to solve this problem, because like this was very easy in terms of the idea. And C was not that easy in terms of the idea. So this is what I've done in the code, but let's discuss the first discuss the solution to this problem first. So any ideas on this, how you can solve this?
Yeah, I actually had this idea. So I was using segment tree, and I was querying for let's say we are given a range as in range of columns, CL, CR.
Okay.
Basically LR. And
let me just
LR.
construct this question here, and then you can tell me what you're doing. Okay. So
Sure,
in this problem, what you're given is that you have a grid. This is the grid. Okay, these are the columns, and these are the rows. Okay, you go here like this. What is given to you in this problem is that for every column, for these columns, there is a particular height that is blocked for every row. For every column, sorry. For every column, you have a particular height that is blocked. For example, if this column says that my 3 heights are blocked, then you block this range. Okay, this is blocked. For this height, let's say it says that my 5, for this column, let's say it says that 5 height is blocked. So all these points are blocked. Let's say here it says just 1 is blocked. So this is blocked. Okay. So this is similarly this is like a grid here. Okay. What you have to do is you're given a starting point. The starting point could be something like this, and you're given an ending point. You have to tell whether you can reach the starting point, you can reach this ending point from the starting point, provided you can take jumps of size k. And these jumps could be either either right, either left, up or down. So you can take a jump of size k. For example, if I tell you k is equal to 2, you can take a jump of 2 here. You jump 2 here and you reach here, okay? Yeah, you reach here by jumping 2. So you jump 2 again, you reach here. You jump 2 again here, you reach here. And let's say there was one more column here, and there was this column, and this was here. Then you jump 2 again and you reach here. But let's say I told you that, your actual value, where it is actually present is somewhere, let's say, or let's say this is the grid, and your value is present here. So can you reach this from here to here if this is the structure? Basically, what you have to tell me is that can you reach the ending point from the starting point or not, provided you don't get into all of these blocked regions. Okay, this is the whole idea. So the very first observation that you should make is this. You can only make a jump of size k, right? So let's say I tell you that you have to jump, you have to jump from column A to column B, and you can only make jumps of size k. What does this mean? Does this not mean that B minus A should be a multiple of k? I have to jump only k times. I mean k steps at once. So the difference between the columns that you have to jump should be divisible by k. And also, should I say this same for the row as well? What is happening is this. You can jump in the left or in the right, anywhere you can jump only k times. I mean, you can make a jump of size k. So what I'm saying is that if you have to go from column A to column B, then the difference between this point and this point should be divisible by k. B minus A should be a multiple of k. Similarly, if you want to go row wise, you want to go up or you want to go down, then the difference between the rows that you have to traverse, they will also have to be a multiple of k. Fine, so this observation is clear to everyone, right? That in order to go from a particular point to another point, the difference between the row and the difference between the column, both of them should be divisible by k. Fine. Okay, now let's talk about the approach that somebody here was discussing. Let's see, what is your approach?
Yeah, so basically, let's say we put everything in a data structure. Let's say I use segment tree, and the query was, let's say you are given two columns, C1 and C2, and it will just tell you what's the maximum value between these two, inclusive.
Okay, what you're saying is this, right? Let me just jot it down. You're saying that you have to go from column, let's say C1, or let's say this is C, let's say CL, to column CR, right? And you have a segment tree on this whole array. This array is defined by the height, okay? And what you're saying is that you query for a range L to R, and it just returns to you the maximum height that is there between these 2 points, right? Between these 2 columns.
Exactly, yeah.
Okay, cool. So you have a segment tree for that, okay? That is order of log n to just query once. Okay, now tell me.
Yeah. Okay, so now, anyway, if we have to go from this point to that point, then we have to cross the maximum height.
Right, you will have to cross the maximum height. You cannot go something like this. Fine.
Yeah, so there is a corner case that if the height is like the topmost, then you cannot do that. But let's say it's less than that, then you can always find this. You can always find some Manhattan distance to cross this. For example, I mean, it's not exactly Manhattan distance, but from that point to the max, and then from the CR to max, and then the horizontal distance.
Okay.
This whole thing should be a multiple of k.
What you're saying is this, that you have this L to R range, and you have a segment tree. This is like a black box for now. This is a segment tree.
Yeah.
You query L to R, and it just returns to you the height of the maximum number of blocks blocked in a particular column from L to R. Right.
Yes.
Let's say this value comes out to be something like 10. Okay. 10 is the maximum height. And the size of the grid that is there is something like, let's say 20. Okay. You can go up till a height of 20. Okay. What you're saying is that if it already comes up to 20, let's say, the maximum height that you can, the maximum height that is there in between L and R is already 20. Then it does not matter which point you are here and which point you are at here. You will never be able to reach, right? This is your first edge.
Yes, correct. Okay. Yes, that's the first corner.
The second thing that you're saying is that if there is some space remaining here in the top, you would want to cross this region by this space. This is what you're saying.
Yes. Yeah.
So
and
go on.
Yeah. So I mean that is fixed. Like there is a parity thing going on. So let's say CL CR. We know the exact point. So we know. Sorry, row L row R. We know that.
We know this row L. I mean this is RL and this is RR. Basically, these are the actual points. So the row number in column L and the row number in column R. Let's say this is the point. Okay. Yeah. Now tell me.
Yeah. And let's say you are saying 10 is the max height. So we have to jump, like we know the jump size to cross this particular this thing. So that is some 10 minus RL plus 1. I mean, we can do that. Plus the absolute difference between RL and RR. So this whole thing is the distance between these 2 points, and that has to be a multiple of k, or else it cannot.
Yeah, I mean, let's not get into this case whether it is a multiple of k or not. We have already identified that it is a multiple of k. So now the question really is to cross this 10 height. That's the whole question. Will you be able to cross this height or not? That's the entire question now. Once you have already checked for this edge case, right? I mean, this thing. That,
yes.
The very first condition, even before you query any segment tree, is this. The difference between the column CL and CR, this should be a multiple of k. Similarly, the difference between the rows that you have, RL minus RR, the absolute value of this should be a multiple of k, right? This is the very first condition. Now, if this is the condition, then it already means that I can reach these points. I mean, I can go from the first point to the second point by making jumps of size k. But now the only condition is that I have to, let's say this is L and this is R, I have to cross something, right, in the middle here. That's the whole condition now. Fine.
Yeah.
So what you're saying is, like, I mean, there could be many ways to find this. What I did was something like this, that if let's say this is your point, this is L point, and this is, let's say, R point, okay, or in fact let's consider a grid here. Yeah, let's say you are here, okay, and let's say this is the thing and this is blocked. Okay, and you have to go from, let's say, here to something like, let's say, here, okay, and nothing is blocked here. Let's say one block is blocked here and one block is blocked here. So if you have to go from here to here, and if I, let's say, tell you that the grid size here is this much, that you can use all the above space that is there. My claim here is that should you not just like if you're standing here, should you not do something like this, that you go all the way up till the top, up until you can reach, and then you come here? Should you not just do something like this, or should you just go here? Like, both of them are same only, na? If you go
Both
like
of
this,
them are same. Yeah,
right? If you go
parity-wise,
here, yeah. If you go like this, or if you go this green path, if you go this blue path, or if you go this green path, both of them are same. What I am saying is that why should we even consider the blue path? Should we not just consider the green path and check that the highest point that I can reach, if this is greater than the maximum height here or not?
Yeah, this is better.
Now how do you do this? How do you find the highest point that you can reach such that you remain within the grid? Can you do something like a binary search? Can you do something like a binary search, or is there some order of one solution as well for this? What I'm saying is that you have this point, and you want to get to this point. This is the maximum height that is there for you right now, okay? My point is that should you consider this blue path or should you consider this green path? The point is that it does not matter how many steps you're taking. All you have to say is whether you can reach this point or not. So in order to do that, should you just not consider the best path? The best path would be to just go up as long as you can and then come down. Right, and then the only condition would be that you just check which is the maximum row that you can reach. If the maximum row that you can reach is greater than the maximum from the segment tree that you're getting here, again, in order to check for this thing, that what is the maximum in a range in an array, you can use a segment tree first of all. What else can you use, by the way? Anybody familiar with range queries here?
Sparse table.
You can also use a sparse table, okay? So a sparse table gives you an answer in order of one, unlike segment tree, okay? But we haven't really discussed this ever in TLE, so let's not discuss this right now. But yeah, so how do you find this topmost point? This point, the point that you can reach by taking a height of, steps of size scale. Let's say I tell you that your current point is something like 3, and the maximum that you can reach is something like 10, and you can take a step of size 4. What is the biggest value that you can reach to? You go to 7, right? And can you take a step after 7 if you can only take steps of size 4? Tell me this. Can you take a step after 7? If the size of steps that you want to take are 4 and you're standing at 3 and the maximum that you can go for is 10, can you take 2 steps or can you just take 1 step here?
1 step.
What I'm saying is this. You are standing at a point, this is the height, this is the maximum height that you can reach. And you can take steps of size, let's say 4, you come here. You take another step of size 4 and you come here. If you take another step of size 4, you go outside the grid. You cannot do that. The point is that you should remain inside the grid. So can you not do something like a binary search on the number of steps that you're taking? That's my question. Just do a binary search, check if, just check this. If can you take, let's say 5 steps. Then if you take 5 steps, how many actual steps you would have taken? You would have taken 5 into 4. Just check if, your current value x, let's say it is x plus 20 is less than the height of the grid, then less than equal to the height of the grid, then you can take that and you can do a binary search on this. But is there some order of one solution as well for this? That's what I want to know.
Can't we take just the difference from the maximum height and the point where we are, and then divide it by the k?
Exactly. Yeah,
Clear.
that is what I wanted you guys to come up with. So actually, if you look at my submission in the contest, I did not think about it like this. I was like that if I'm doing order of log n stuff for one query, how does it even matter if I do a binary search here, right? So I did a binary search for this. But like somebody said, if I'm standing at x and the maximum that I can reach is y, all I have to do is just do y minus x and take the floor value of this by the number of steps that I can take. This is the number of steps that you'll take, and this will become x plus what? X plus this value into k. Right? So this is order of one, but you can always do a binary search, right? So now what's the solution to this problem? The very first condition is this, condition 1. You go and check whether the difference between column CL, CR, the absolute value of this is divisible by K or not. Okay, this is the first condition. The second condition is rho of L minus rho of R is divisible by K or not. That's the second condition. Okay, what's the third condition? All you have to do is you have to take this point, and if you have to go anywhere, like what you can do is you can consider these points interchangeably. Okay, tell me this, is it different if I go from here to here or from here to here? Are these two different or not? If I take the path from L to R or I take the path from R to L, are they any different or are they just same? If one of them, they're same, right? What I'm saying is this. You have this L point and you have this R point. So either you take this step like this, or you go from R to L. Aren't both of them just same? My question is this. They're same, right? Because like it doesn't matter how you're going. If you can go from L to R, you can also go from R to L. So all you have to do is just out of these 2 points, take any point. All right. So this is L, this is R. Inside this, query for a segment tree, query a segment tree or a sparse table and check the maximum height that is there in this range. Okay, let's say that range comes out to be something like Z. Okay, now go to this L point or to this R point, any of these points, and check what is the maximum height that you can reach such that you remain in the grid. Let's say that height comes out to be X. How do you find that X? You just take the difference of the maximum height from your point, let's say that is P, and you divide it by K. You take the floor value and you multiply it by K, and that's the number of steps that you will take. Fine. All you have to do now is to check whether X is greater than Z or not. If it is greater than Z, then you're done. And if it is not, then it obviously means that you will not be able to do something like this. Right. So what is the time complexity and what is the space complexity of the solution? What are we using? Let's say we use a sparse table, or let's say we use a segment tree. What is the time complexity for this? The space, and you give me the space and you give me the time according to this problem. The space would be order of n. What is the time? The time is q into log n. Okay, q is the number of queries. Fine. So, and similarly, if you have a sparse table, then the space would be order of n log n. The construction time would be order of n log n, but for every query you can answer it in just order of 1. So I used a sparse table here, although I like even did a binary search, so that's already log n. So this is what I did. I just checked first of all if this is like a trivial condition, don't consider this, but this one I just checked whether the difference between the rows and the columns are a multiple of K or not. If they're not, then I already say no. Otherwise, what I do is I just check, I just find the maximum height that I can reach, and once I have the maximum height, I just check if that maximum height is greater than the maximum blocked cells in the range or not. And if it is, then the answer is yes. Otherwise, the answer is no. Fine. Okay, idempotent. Let's not get into this. What is idempotent and all of that, because this is somehow related to sparse tables. And I have never taught this in TLE, or this hasn't been taught to you, so let's not discuss this right now. Okay. Fine. So any other doubts? I think we're done with all of these problems. Any more doubts? Any other approaches to this problem maybe? Can you explain your code for problem C? Sure. So yeah. What do you want to understand here? Like what I'm doing is I'm just placing a minus 1 opening brackets. Then I'm placing 1 closing bracket, and then after that I'm just doing the same thing. Putting 1 opening bracket and then putting the rest of the closing brackets. And then just checking if it is regular or not. If that sequence is regular bracket sequence or not. If it is, then I print no. If it is not, then I print yes. So I get the number of opening remaining brackets by this thing. I get the number of closing remaining brackets by this thing. And then after that, I just put, first a minus 1 opening brackets. Then I put a closing bracket. Then I put another opening bracket. And then I put the b minus 1 closing brackets. Fine. Somebody wanted to speak something, I guess. Here. You're free to speak. Last wala bouncer chala gaya. Maybe because you don't have a lot of idea about range queries. It's very simple if you look at it. You have this grid, you have these blocked cells. Okay, you have these blocked cells. You want to go from a cell to this cell. All you have to do is you have to cross these cells in the middle. No? Then you just say that you go up as long as you can, and then just check if you can cross your path or not. If you can cross your path, then you can reach this point, otherwise you cannot. That's the whole idea. And we are doing this using segmentary to find this maximum and all of that stuff. Fine, so yeah, I guess let's end this now. I am done with this whole session. Can you discuss the idea for E? I think it's somehow related to, some centroid decomposition. I had some ideas around centroid decomposition, but again, I'm not very good with it, so I could not get a concrete idea on it. But yeah, I could visualize some centroid decomposition stuff happening here. Although this might also have a DP on tree solution. But yes, I don't have a concrete solution here.
Actually, the tag says only trees. So I believe some LCA Euler tour or centroid is happening.
Okay. If it says only trees, then yeah, it might not be DP on trees.
Yeah.
It might be some centroid.
The construction, there is one hint that 2 power 30 is there, and maybe 30 I was thinking as this thing DP on tree and 30, but I don't think there is any. But yeah, LCA, like if you consider every node as the LCA and the paths, does there exist a path like in its subtree such that taking that LCA inclusive, does it give 0? Then just modify that, something like that.
Yeah,
and do this for all
find that out in order of n, but finding this out for every subtree would be order of n square, and you don't know which nodes do you want to change. That's the whole idea behind this problem. If you don't know which nodes you have to change, then it's already like going into some exponential solution, right? You can't even do DP on that because you don't know if you're not removing, let's say, a particular node, will you be removing some parent of it or not? You don't know that in this problem. So unless you know that, you cannot do something like a DP on trees.
So, this is, I'm asking for something much, but I have some idea regarding centroid decomposition. I just want to know why do you, what's your, why do you think this problem might be solved using centroid? It might be wrong, might be correct, but I just want to know your thought process.
That's just because, if you look at centroid decomposition is mostly related with paths.
Yeah.
That is what it helps you with, right? And another thing that it helps you with is this, that if you, let's say, have a centroid, then the subtrees out of the centroid would have a size of less than n by 2.
Correct.
Right. So if I were to do something or something like an order of n solution here, like you were saying, right, that you have to check how many paths cross this LCA, and they have a ZOR of equal to 0, right? That's exactly what happens in a centroid. You just check that how many paths will cross this centroid, and they will have that that ZOR equal to 0.
Okay, I got it. Okay.
That's exactly what happens here. And even if you do that in order of n, like I was saying, that in order to check how many paths have this, this thing, you can do this in order of n, although I don't have a concrete idea again for this right now.
The structure is fixed, but it depends on if you change it, then we have to propagate it to the parent as well. But centroid would, this might be a solution. I was thinking.
But again, anyway, I don't have a concrete solution for this. And again, I haven't really, solved any centroid decomposition problem in a contest. Although I've done 1 or 2 of them in practice, but solving a problem on a concept in a contest is like an entirely different thing, right?
Yeah.
So cool. Let's end this whole stream, and I guess I'll be uploading this on YouTube if I don't have any cuts or any lags in the middle. But for anybody who wasn't able to understand anything, you are free to watch the recording and rewind as you like. But yeah, that is it for this session. Okay, see you all. Bye bye.